Alright guys, sorry this took so long. I've been trying to figure out where I wanted to go next. And I think this is going to be the last one that we're going to do. I'm going to keep the assignment a little bit shorter because these problems take a little bit longer to work on. Okay? So today we're going to be working with multivariable linear systems. So that means we're going to have, well, 3 variables, 3 equations. Basically, there are 3 different outcomes that can happen from these. Either 1, you wind up with a number answer for all 3 variables and you're said and done, easy. 2, it could be a no solution. Or 3, it could be an infinite solutions. Now, as you can tell here, I got 3 different examples. We're going to have one of each. I'm not telling you which one's which. So, without further ado, basically what we're going to be trying to do, we're going to try to change it from having 3 equations with 3 variables to basically 1 equation with 1. We can do this by combining rows, by multiplying rows, doing all different kinds of things. So we're going to start off with this one right here, and we'll go from there. Okay. Now, fair warning, these do take some time, and they do take up a lot of space. So this could take a little bit. Let's see. Right there. Okay. All right. So looking at this. Now, when we're given this kind of setup, first thing I want to look for, are there any missing variables? So I'm going to make sure I have all my x's lined up, all my y's lined up, my z's lined up, my equal signs lined up, and my constants lined up. We got that all right here. We're missing a z right there. So what this would allow me to do, I can manipulate these first and third equations so that way we can eliminate the z to change it from 3 variables with 3 equations to 2 with 2. Okay? So what I'm going to do, I'm going to do just that. So I'm not going to touch row 2. That's going to stay the same. I'm going to look to eliminate z. So I'm going to take -5 times the first row, and I'm going to add 3 times the bottom row. So we're going to take -5 times the top row. So I have a -5x. Actually, I'm going to do that in a different color. -5 times the first row, so we have -5x plus 10y minus 6z equals -45. 3 times row 3, 6x minus 15y plus 15z equals 51. And I got to go back up here and fix this. This would be 15z. So now I'm going to add these two together. So we get x minus 5y equals, that would be 6. So now what we have done, we've changed it from 3 with 3 to 2 with 2. Now I'm going to look to eliminate another variable. Easiest one will be x here. So I'm just going to combine the 2 rows. Cancel out. -2y equals 2. Y equals -2. So we got our first part done. We found our y. Now that we have that, all it is just substituting back into the previous equations to get the other variables. So let's start off. We know y is -2, so I'm going to plug it into the bottom one here. Wait, sorry, that's not -2, that's -1. I don't know what I'm thinking today. A little off. So let's plug -1 into this bottom one here. So that becomes x plus 5 equals 6. We have our x, we have our y, now we just need our z. I don't care which one of these you plug it into. I'm going to try to keep it as simple as possible, so I'm going to go with the smaller numbers. Personal preference, again, it doesn't matter which one you do, because they should all get you the same spot. So I have 2 times 1 minus 5 times negative 1. I said top one, I'm doing bottom one. Jeez. Plus 5z equals 17. 2, 5. So 2 plus 5 is 7. So we have 5z equals 10. So therefore, z equals 2. Now, when you get done with your answer, I'm not going to accept it like this. I want it in an ordered triple. So therefore, you do it in alphabetical order. 1, -1, 2. That is what I'll be looking for an answer. Now, somehow I was able to do this all onto one board. It may take up quite a bit of space for you. This is a possibility where you get 3 answers, or an answer for each one, and it comes out nice and neat. So it's not too bad, it's just a little time consuming. Next one. Okay. Next one that I have for us here. X minus 3y plus z equals 1. 2x minus y minus 2z equals 2. And last but not least, x plus 2y minus 3z equals -1. Now again, 3 variables, 3 equations. Now this time there's none with a missing variable to make it easier on ourselves. So I'm going to look to see what's going to be the easiest variable to eliminate from, well, all 3 of them. What I'm kind of seeing, the one that's going to require the least amount of work for me, are the x's. Because what I'm going to do, I'm going to take row 1 times -2, and I'm going to take row 2 times -2. I'm not going to combine them quite yet, but I'm going to multiply them so that way I get stuff lined up. So -2x plus 6y minus 2z equals -2. Middle row stays the same. 2x minus y minus 2z equals 2. Bottom one times -2. -2x minus 4y plus 6z equals 2. Now the reason why I did this, all of our x's are the same. So therefore, I'm going to take row 1 plus row 2 and row 2 plus row 3. Row 1 plus row 2, x's are gone. 6y minus y is 5y. -2z plus 2z is minus 4z. -2 plus 2 is 0. Add these two together. X's are gone. -5y plus 4z equals 4. Right now, some alarm bells should be going off. Because if you look at our 2 equations here, they're just the opposites. So when we add them together, we get 0 equals 4. Contradiction, 0 cannot equal 4. Since that literally cannot happen, this will be a no solution. That only happens when you have a constant equaling a different constant. That will happen on this. So it's either you can get, well, a straight normal solution, which is just 1 point. You can get no solution like this, where you got a constant equals a different constant. Or there is the third option that will happen. Now this one is the newest one, so this is going to be the most challenging one for you guys when you run into it, because it requires a little bit of thinking outside the box. So for the original problem, we have x plus y minus 3z equals -1. We have y minus z equals 0. And we have -x plus 2y equals 1. So this one's already quite a bit different because there are multiple missing variables. So we are going to have to choose which two variables we want in the next round, because ultimately we want two equations with two variables. I don't care. I really don't care which two variables you want to use. So for me, when I'm looking at this, I am looking to eliminate the easiest one possible so I can work with the other two. With that being said, I have x and -x. Well, guess what? I'm going to choose to eliminate x. So I'm going to add row 1 and row 3. So I'm going to leave row 2 untouched, which means I'm going to be left with y and z. So x plus -x, gone. Y plus 2y is 3y minus 3z equals, well, now we have this. -1 plus 1, 0. We did not do anything with the middle one here. Oh, that's y minus z, not minus 3z, equals 0. Now again, red flag should be going up, because if we took the bottom one times 3, it's exactly the same. This is perfectly fine, because that means we're going to have infinite. Now, infinite for multivariables for more than 2 has a different definition than infinite for 2 with 2. If this was all we had originally, we would just say infinite solutions done. However, we got to account for the x too. So with that being the case, for one of these variables down here, I'm going to pick an arbitrary value for it. Now, an arbitrary value is basically a variable. I'm going to say z is going to be equal to the number a. Yes, I said the number a. So that means when our answer is done, anything with a z, if we replace z with an a, or if we replace a with a value and plug it in for z, that would help us create like ordered triples that we could use. So this is a formula. We use this to make a formula for the infinite solution. So since we're going to say z equals a, we're just going to plug a in for z and then solve for y. So y minus a equals 0. Well, therefore, y also equals a. We've got our first two here. Now we got to solve for x. Just like before, it does not matter which one you plug it into. Okay? So what I'm going to do, I'm going to plug in a. I'm going to do it into the bottom one. There's less stuff there. It's going to be easier to work with. So I'm going to have -x plus 2 times a equal 1. Now we solve for x. I'm going to subtract x and subtract 1, so I have 2a minus 1 equals x. That's what I'm going to use. So now we have a value for z, we have a value for y, we have a value for x. Now it's ordered triple time. X is equivalent to 2a minus 1. Y is equal to a. Z is equal to a. Even though it's infinite solutions, it has a pattern for the infinite solutions. Okay. So, I'm not going to assign you guys a whole lot here. It takes quite a bit of time to go through this stuff, to think about it. If you have questions on anything, please let me know. If you guys want to do some other stuff, also let me know, because then I can get one made up for next week. But otherwise, I am planning on this being the last one for you guys for this semester. I appreciate everything you guys have done for me. I know it's not always the easiest. I do plan on making this harder in the future, because sometimes it was really easy for some of you guys. But I appreciate all your honesty, and if you guys ever need anything, you know how to get a hold of me. All right. Don't have too much fun, and I look forward to see how you guys do.